Previously, you have learned how to perform the linear interpolation in 1D. For example, if these 2 points are given, you are going to predict the interpolate data between the x-axis. This can be done by using the 1D linear interpolation. For example, for the point 1 and point 2 given here, given the xi between the x1 and x2 here, you are going to find and interpolate the function at xi here. If the function is also given here in the y direction, then your function is no longer 1D, which is in the x direction, but in 2D, in xy direction. For the first point, you have x1, y1, which is located over here, and the function for x1, y1 is this value. For the second point, you have x2, y1, which is located over here, and the function for the x2, y1 is this value. The point is located at the x1, y2, which is here, and this is the function at x1, y2. For the last point, you have x2, y2, which is located here, and this is the function for the x2, y2. If these 4 points are given, you are going to predict the function in between this plane, which is between y1 to y2 and x1 to x2. So you are going to interpolate the function at xi, yi, which is located at this plane. In this case, we can use the bilinear interpolation to solve the 2D interpolation problem here. To perform the bilinear interpolation, in the first step, let's interpolate in the x direction and assume a constant y1. Based on the function given at point 1 and point 2 here, where in this direction the y1 is constant and it changes from x1 to x2. Then by using these 2 points, we can use the linear interpolation, which is shown in the equation 1a, to find the function at xi here and y1. So this is the point that you want to interpolate, and this point is between x1 to x2. In the step 1b, you continue the interpolation in the x direction, where you assume the constant y2. In this direction, your y2 is constant, and then you interpolate from the x1 to x2. Point 3 and point 4 are given, which is located at x1 and x2, which is this point, and x2, y2, which is this point. So the function at these 2 points are given, and then you are going to interpolate the function at xi, where your xi is between x1 to x2, and at constant y2, which is this point. This can be obtained by using the linear interpolation formula. From step 1a and step 1b, you should be able to obtain the function at xi, y1, and y2, which is located at these 2 points. Now we take the xi to be constant, and then we interpolate from the y1 to y2. By using these 2 points, we can use the equation 2, which is the linear interpolation, to find the fxi, yi at this point. We have 4 given points here, and in graph you can draw this point at here, and you want to interpolate the fxi, yi, where your xi is from this point to this point, and your yi is from this point to this point. So you form a plane. So this plane is the function that you want to interpolate. Previously, you performed 2 linear interpolation in the x direction here to obtain the equation 1a and 1b. Then you perform linear interpolation in the y direction here to find the equation 2. In the step 3, you need to substitute the equation 1a and 1b, which is these 2, into the equation 2. After you substitute the equation 1a into the equation 2 here, you obtain this component, and then substitute the equation 1b into the component here, you obtain this component. This equation is called the bilinear interpolation that can be used to find the fxi, yi, which is located between these 4 points. In this example, you have a rectangular heated plate where the temperature at these 4 points are given. The coordinate of the plane is given as well. So at this point you have x, at this point you have y. So this is your x-axis because your x is changing, and then this is your y-axis because your y is changed from 1 to 6. Then let's assume this to be our first point, and we extract the information for first point where you have the x equal to 2, y equal to 1, and the temperature function fxy is equal to 60. For the first point you have x1 and y1. So let's move to this point. We have point 2 where your y1 is constant, which is 1. Then you have the x2 changed to 9. With that, you obtain the information for your point 2, and the function is equal to 57.5 degrees Celsius. You continue with the point 3 here, where you can see the x1 remain the same to be 2. So this is your x1 here. And your y1 changed to y2 from 1 to 6. And the temperature function here is 55. So for the last point here, so you have the x2 and y2, which is these 2 points, and the temperature is 70 degrees Celsius. So these 4 points are given. You are going to interpolate the temperature within these 4 points, which is this plane. So let's say we take a point from this plane. This point is in the coordinate xi and yi, and we want to find the temperature at this xi, yi. We can use the bilinear interpolation to solve the 2D interpolation problem here. By substitute all of the information given by these 4 points into this formula, then you can simplify the formula into this, and this function is in terms of the xi and yi, where your xi is between this point 2 and 9, and your yi is between 1 year to 6. If you want to find the temperature at this point, which is the temperature at point 7 in the x-axis, 5 in the y-axis, then in this case your xi is equal to 7 and yi equal to 5. Substitute inside the formula and compute. You should obtain this answer. To find the temperature distribution within these 4 points, let's separate and split this into 100 point, 1, 2, 3, 4, and so on until 100. And in the y-axis, it also split into 1, 2, 3, 4 until 100 here. With that, you obtain 100 times 100, which is equal to 10,000 temperature. With that, you obtain 100 times 100, which is equal to 10,000 points on this plane. Substitute all of these points into this formula, then you can obtain the temperature at this 10,000 points. It is impractical for us to manually calculate it by hand, so we should use computer to do this. So this is the programming by using the Matlab. So first of all, you split the x from point 2 to point 9 here and split it into 100 points. Then you split the y from 1 to 6 into 100 points as well. Then you perform the mass grid to combine the x and y coordinate into a matrix here. By substitute the xy coordinate into the bilinear interpolation formula here, then you can find the temperature at this point. Then you can perform the surface plot where you have the xy coordinate as well as the temperature. So this is the x coordinate from 2 to 9, and this is the y coordinate from 1 to 6, and then the height is the temperature. By looking at this 3D graph in the top view, then you obtain this plot. So this is the temperature distribution that you obtain, where you can see the red color means the temperature is high, and the blue color here means that you have a lower temperature. You should know now how to perform the bilinear interpolation to find the temperature distribution within 4 points.